students, this is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. Today in this session we are going to see about flame emission spectroscopy. It is also called flame photometry. So emission of light of its own characteristic wavelength by alkali and the alkaline earth metals, and also correlation of this intensity with the concentration of the solution is known as the flame photometry or flame emission spectroscopy. Now we can see the concentration of the alkaline and alkaline earth metals by the conventional method is by gravimetric analysis, and it is a very tedious process and also time consuming. So we are going for this instrumentation, that is the flames emission spectroscopy. Now we can see the principle that is involved over here. Okay, the first is the solution. The solution, metal solution, the solvent evaporates in the metal solution and you get the solid residue. The solid residue in the solid, it vaporizes and it is converted into gaseous form. And gaseous form, it gets thermally excited and it atomizes, and the thermally excited, the atomized atom, that is the metal atom alone, it gets thermally excited atom. And thermally excited atom, it cannot stay in the excited state for a long time. So it returns to the ground state by emitting its own characteristics wavelength, and you get the metal atom in the ground state. So this is the principle that is involved in the flame photometry, flame emission photometry. Here we you have the atom that is excited and it emits its own characteristics wavelength. Atoms are excited only thermally, and you don't use any external electromagnetic sources as that of in the ultraviolet visible spectroscopy or the atomic absorption spectroscopy. So this is an emission spectroscopy because the thermal excited atom, it emits its own characteristic wavelength by returning to its ground state. So the instrumentation that is involved over here is, see, you have the sample. The sample is present over here and the sample is mixed in the nebulizer. Okay, the sample is mixed in the, it's converted into mist in the nebulizer, and you have air and the fuel, that is compressed air and the fuel is there in the mixing chamber, and the mixing chamber, the solvent, it mixes over that is the atomized form or the mist form of the sample. It is mixed in the mixed chamber and it is introduced into the flame. So the flame when it is introduced to the flame, all this process takes place. Okay, first the solvent, it evaporates, then after that the solid residue that is present over here, it is converted into gas, and the gas, it atomizes, and the automated metal, it is due to the thermal high temperature over here present over here, it is thermally excited. So all these process happens over here, and the excited atom, it goes to the ground state. When it goes to the ground state, it is passed through the monochromator. So what is the purpose of the monochromator? You have a lens, and after that you have a monochromator. The lens actually, it converges the light and it is sent to the monochromator. So monochromator, what happens? It will select a particular wavelength. Okay, so you are fixing a monochromator in a particular wavelength and you are allowing it to pass to the detector, which is as usual as a photodiode or a photocell, and you have the next is a data processor where you get the data. That is, you will have different intensity of, that is, you will have a graph that is related to the different intensity, that is concentration. It is correlated with the intensity. If the concentration is very high, the intensity of the radiation of the wavelength, that is, you are getting, the light you are getting is very high. If the concentration is low, the intensity will be low. Okay, so over here, why we are using the monochromator is, for example, if you are using a water and you are finding the elements that is present over here. For example, if you are going to find sodium that is present in the water, the wavelength will be fixed to 589 nanometer in the monochromator, that is the prism. You can use the monochromator as a prism. You fix the wavelength and you have to detect the that is the intensity of light that is coming out of